All right, welcome. We're going to talk about complex circuits today. We've already kind of talked about a little bit of this, and I want to go on to number 3, and I'll work through this one with you guys in order to be able to figure out the equivalent resistance of a complicated circuit that looks something like this. So I'll redraw it first, just to kind of demonstrate, so you can see it a little better. We've got a 2.5 ohm resistor here, which we're going to call R1. A 3.5 resistor we got there, which we're going to call R2. So R1 is equal to 2.5 ohms. We've got R2 that is equal to 3.5 ohms. We've got an R3 that is equal to 3 ohms. We've got R4 that it actually goes just like that. And this R4, we know, is 4 ohms. And then we've got a little branch coming down here with R5, which is equal to 1 ohm, okay? So what we've got to do, essentially, is we've got to look up here and we've got to get this, we got to pretend, like kind of boil it down until we get to the point where we could almost pretend as if it was one resistor. And so what we're going to do is we're going to start looking at this. I'm going to start by combining R1 and R2. And in that, we know that R total is equal to R1 plus R2 for any that are in series. So your R total for 1 and 2 is going to be equal to R1 2.5 plus 3.5. So the resistance of 1, 2 is 6 ohms. Now we're going to pretend at this point as if the circuit now looks like this, okay? We're going to go up. It's going to have R12 here and R3 here. We've also got R4 still, and we've got R5 down here still, okay? So essentially we've taken those two, combined them as if they were one, and that is 6 ohms. And then we've got R3 that is 3 ohms. And we've got R4 here that is equal to 4 ohms. And we've got R5 that is equal to 1 ohm, okay? So essentially now we've got two parallel circuits that are in series with each other. This is a parallel circuit, and that is a parallel circuit, and together they are in series with each other. So the first thing we're going to do here is we're going to revise R12 and R3 and turn them into one resistor. R123 is what we want to get. Because they're in parallel, I have to use the parallel equation, which is 1 over R123 equals 1 over R12 plus 1 over R3. We've got 1 over R123 is equal to 1 over 6 plus 1 over 3. I'm going to go ahead and find a common denominator. The common denominator is 6, so we have 1 over 6 plus 2 over 6, and we end up with 1 over R123 equals 3 over 6. Cross multiply, we get 6 is equal to 3, R123, and then R123 divide by 3, and I get the equivalent resistance of 123 is equal to 2 ohms, okay? So you've actually simplified your circuit. We've simplified the circuit to the point now where we have a circuit that looks like this. This is R4, this is R5, and this is R123 that we now is equal to 2 ohms. This is 4 ohms again, and this is 1 ohm, okay? So now the next step would be combine 4 and 5 together. They are in parallel, so we're going to do 1 over R45 equals 1 over R4 plus 1 over R5. 1 over R45 is equal to 1 over 4 plus 1 over 1, which I'm going to turn into 1 over 4 plus 4 over 4. And when you combine in, R45 is equal to 5 over 4. Cross multiply, 4 equals 5, R45, divide by 5, and we get R45 that is equal to 0.8 ohms, okay? So now we have the resistance of 1, 2, 3, and we have the resistance of 4, 5. So we've simplified the circuit at this point to a very simple circuit that looks like this. It's going to have R1, 2, 3 here and R4, 5 here. So this is R1, 2, 3, which we know is 2 ohms. And this is R4, 5, which we know is 0.8 ohms. And so if we just want to get the equivalent resistance of the whole circuit, we do a simple formula, R equivalent, which is the 1, 2, 3, 4, and 5, okay? You can do it like that, 1, 2, 3, 4, 5 if you want, is equal to R1, 2, 3 plus R4, 5. And R1, 2, 3, or the equivalent resistance, is equal to 2 plus 0.8. And then when you do the math, you get the equivalent resistance of 2.8 ohms. Let's make sure that's what they wanted. You read through the question. It says, what will the net current for the circuit? Well, wait a second. I've got the equivalent resistance, but that's not what they wanted. They wanted the net current. So that's where the V equals IR equation comes in. We know our I now is our R is 2.8. And if you look in the problem, they've given us that this battery is 12 volts. So all we have to do at this point is we have to plug in those values. 12 equals I times 2.8. And when we divide both sides by 2.8, and I get a current that is, can somebody help me out? 12 divided by 2.8? 4.29, yeah, I think is what it was when you do the rounding correctly. And so that was my answer. Sorry, not trying to call you out. So that's how you revise a fancier complex circuit into a simpler one. You can see that you kind of just have to do them step by step. Combine in series to start, combine parallel, and then combine series is what we did on this problem. So every problem is going to be slightly different, but they're all manageable. Please, real quickly, can you guys do number 4? And then after you do number 4, we'll do a lab that kind of